Hello, welcome to Mechan 2040 Solid Mechanics. I am Globus. This is the fifth tutorial of this course, Shear Stress Inside the Beams. For this tutorial, there are three major parts which I want to understand. One is the basic concept of shear stress inside the beam, and I have two examples to help you to understand the concepts. Besides, we will talk about the longitudinal shear on arbitrary element, but the equation for 5.1 and 5.2 are basically similar. For 5.3, we will talk about the shear stress in the thin-walled beams. In the last tutorial, we discussed about the direct stress inside the beam. It is highly related to the moment acting in each cross-section of the beam. Imagine you have a beam and there is an external torque, external moment acting on it. Then it will compress or elongate the material of the beam, and you also remember that there is a neutral axis. In the last tutorial, we tried to draw the distribution of direct stress by using the moment diagram, because we know that the stress is just the negative of my divided by I. So this is why we use the moment diagram to draw such a distribution. But in this tutorial, all the things are changed. We are not talking about the direct stress, we are talking about the shear stress. So it is very obvious from the name that the shear force diagram will be important. First, let's talk about the shear stress inside the beam. So this is the formula that you are going to learn. The shear stress inside the beam is given by the shear force times the first moment of inertia divided by the second moment of inertia times the width. So tau xy equals to Vx qy divided by Ixx wy, where V is just the shear force inside the cross-section. Q is the first moment of inertia, which I will discuss about it later in the derivation of this formula. Also, Ixx is the second moment of inertia of the entire cross-section about this neutral axis. Wy is the width of cross-section at that particular position of y, so still I will explain to you a little bit later. But all in all, if you are not going to go through the derivation below, then what I can tell you is that the most important thing, the most important formula for this tutorial is tau equals to Vq divided by Iw. So this is the most important thing that you are going to apply in the problems, but in the following I will still try to derive the formula for you.